Hello everyone. Today we'll be continuing in our series setting up a complete Kubernetes home lab. And in the previous set of videos, we've discussed most of all these bullet points, I think up until this point. And next up, we're supposed to go into setting up the storage or the monitoring stack. But instead of doing that first, I will jump to the part where we'll create a more complex application just because I wanted us to have the application ready and then we can monitor the application in the monitoring stack once we have it set up. So without any delay, we'll just jump right into it. So the application that we will be deploying is a simple Golang application that I built using the Gene framework in Gene web framework in Golang. It's been Dockerized and the Docker image has been pushed to Docker Hub. And so it already also has the Kubernetes manifest. So this is the deployment, the HPA, the ingress, and the service. And so I'll have this cloned into the control panel of our Kubernetes cluster. I think I already have that done. So I'll just change directory into that repository and we can see the content that I just showed us on GitHub. So the first thing that we'll do is let's just go to the guide. And the guide says we'll need a database backend, a postgres database backend. And because this whole series is about saving costs, we will not be using or provisioning a database instance on any of the cloud providers or any other platform. We would also set up the database in our cluster to also save cost. And we'll be using the Bitnami charts. So I'll add that repo in Helm. And I think I've already added it, so it's there. And then the next thing is really to just install or deploy the database. So I can do install. Yes, so I'll call it DB for the release name and in the dev namespace, which is what I choose to use, but I don't think I have the dev namespace already. So let's get namespace, and no, I don't have it. So I'll just create namespace dev, and I'll make it my default namespace. Okay, so now I can go back to installing or deploying the Postgres database, and that seems to be done, but I just want to export the Postgres password into my environment variable before I leave here because we're going to need it. And let's just confirm that that is there. Yes, it's there. And we would also need the service name for the Postgres deployment that we just did. So what I would do next is just to check that the DB is running as expected, and it looks like it's running fine. So next thing that we'll do if I go back to the guide is to create the secret that the application would use to communicate with the database. So create so we'll create that, and if we see, so we'll create a secret called DB credentials, and the host is going to be this. So instead of database, it will be DB PostgreSQL. For the DB user, I need to bring this up a bit so that we can see. Yeah, so I'll do that again. we will need to we're creating the DB credentials, and the host will be DB PostgreSQL. The user is Postgres. I won't bother creating a new user because this is just a test environment or test deployment. I would need to get the password to replace this, the password that we had earlier, which is this. So I'll grab that, the one that I stored in the environment variable, and I'll replace this one with that. And once that is done, the DB name will be the same. I'll just use the default Postgres database. Like I said, when you're doing yours, you can set up a proper database for your application, and I'll leave the JWT private key the same. It's just a private key that the application would use, and I'll get that done. And if I get secrets, now I have my DB credentials in there. So the next thing really would then be to actually go ahead and make the deployment. So I'll just do k apply -f deployments. It's in the Kubernetes folder, and then the deployments, and that gets the deployment done. I can show us the contents of the deployment, and it's pulling an image from Docker Hub. It's called Training App, and that's also the label. And it has some environment variables which are being pulled from the DB credentials. So let's check to see if the application is running properly. Let's log. And the application is set up. This is the application level log showing that we've connected successfully to the database. So the next thing that we'll do is we need to, of course, give it a service, Kubernetes service that would expose it externally, or that'll make it available to the ingress, which should expose it externally. So I'll do k apply -f Kubernetes and service, and k get SBC. We have our service, training app service 3 seconds ago. And if we list the contents of the Kubernetes directory, or I can just use tree again. And so we've done our deployment, we've done our service. We will also need our HPA and ingress. So let me just do the ingress first, then I'll come back and talk about the. So let's do k apply Kubernetes -f Kubernetes and then ingress. Let's get ingress, and we'll need to wait for that to get an IP, and then we're going to do the HPA. So let me just talk about the HPA while we're waiting for the ingress to come up. So the HPA is horizontal pod autoscaler, and really what that does is it monitors the workload or the workload that is eating a pod, and it monitors the CPU. This particular one monitors the CPU and the memory. Once the CPU is beyond 20% of the target, or the memory is beyond this usage, it would create other pod to assist that pod in handling the traffic that is coming against it. But note that for HPA to work, you need to have metrics server in your cluster, metrics server Kubernetes. So you need to get that installed, because HPA would get metrics from this to know when to scale or how to scale. So you need to get this set up first. You can install it using direct manifest or Helm, or the Helm charts. So let's check our ingress again. And yes, we see that our ingress is up. If I go to this IP address and go to the health check 192.168.231/API/elf, and we can see, I can zoom in a bit. that our application is alive. And so we can further test by just creating a user just to ensure that the application can talk to the database backend. So I'll paste this right here. We'll use curl and send a post request with this data, username and password, and the URL is not localhost, is 192.168.1.231, and I'll send that post request. Now we can see that the new user was created successfully. So now we can go ahead and create our HPA. And if we do kget HPA, we can see our HPA with the sets, the targets, with targets and the minimum port, the maximum port. So now we're going to use, next thing is to load test the application, and we're going to use Hey for that, Hey load testing. So you can install this from the package manager on your OS of choice. For Ubuntu, I just had to do sudo apt install A, and it's already installed. So it will just tell me that it's already installed. So you can just do that in your own case. So next thing really is to load test the application, and this will send 50,000 requests with a concurrency of 10 to the health check endpoint of that application. So I'll get that run, and that would run. So I'll just use, we need to monitor HPA, but I'll use a real-time tool, K9S. I'll use K9S so that we can monitor our HPA in real time. And I'll fetch the HPA. So let's wait and see how the HPA would scale. So if you go, so you can see that it's already scaled to 141% beyond the 20% that was done, that was set. So instantly that will require other ports to be created. Initially we had just one, now we have a couple of other ports coming in, and a lot more are coming in just to support and then handle the load that is coming at the application. So that's like a quick run through of the application that the complex or seemingly complex application and the load testing. So in the next set of videos, we'll go into the monitoring stack and Argo CD. Thanks for watching, and see you in the next one.